Astronomers have found clear evidence of what could be an Earth 2.0. This artist rendering shows the rocky planet identified as Proxima B orbiting the Proxima Centauri star.
Proxima Centauri is the closest star to our planet apart from the Sun.
2016, astronomers discovered a potentially Earth-like planet orbiting the Sun's closest neighboring star, Proxima Centauri.
A shocking discovery has just been made on Proxima Centauri B, and you won't believe what happened. Exoplanet Proxima B has been burning with intense heat and freezing hopelessly for eternity, and scientists are now amazed to have found life on it, thanks to the James Webb Space Telescope. After this discovery, something unexpected happened, revealing more secrets about Brocima B. What are the secrets of life on this mysterious exoplanet? And have scientists finally cracked the code on extraterrestrial life? Join us as we explore everything about what scientists have just discovered on Proxima Centauri B and what happened next.
Proxima Centauri's potentially habitable planet is closer than Alpha Centauri's stars.
A shocking discovery on Proxima B. Have you imagined the possibility of life within our solar system and outside? That imagination only becomes more concrete as a revelation about life on Proxima Centauri B hits us like a tornado. Proxima Centauri B, or Proxima B, is not your regular exoplanet. It is the closest exoplanet to Earth, discovered by scientists on August 24, 2016, to be 25 light-years away. But then, what is an exoplanet? An exoplanet refers to a planet located outside our solar system. It's like another world of its own, far beyond our reach. While Proxima B is an exoplanet, it is a unique one, fascinating scientists and astronomers with its unique features and numerous possibilities. What could life be like on a planet so distant from ours under a different star? Well, thanks to the likes of the James Webb Space Telescope probing into distinct areas in the universe, the mystery has been unraveled. What unique features have scientists then found regarding Proxima B? The answer is thrilling. Scientists categorize Proxima B as none other than a tidally locked planet, making it more thrilling and terrifying as we explore the possibility of life on Earth. Imagine a world where temperatures are extreme at all points in time. This is the reality of Proxima B. The fact that it is tidally locked means that it doesn't rotate around the Sun.
Just 4.22 light-years away, barely wading distance into the cosmic ocean. The star closest to our Sun, a dim red dwarf named Proxima Centauri.
As a result, one side of it stays fixated on the Sun, facing it eternally and absorbing all its scorching heat. Can you imagine a place hotter than Mercury? Well, that's exactly what we're dealing with when talking about the side of Proxima B, which faces the Sun, making the question of how life could survive on this planet profound. But that isn't all. As for the part that doesn't face the Sun, it is lost to gross darkness and freezing cold, surpassing even the iciest depths of Antarctica for what can be described as an eternity. There are more fascinating features when it comes to Proxima B. One is the shortness of its orbital period, which lasts about 11 days. Interestingly, this means that a year on the planet runs out in just 11 days according to Earth's timeline, leaving possible inhabitants wishing themselves a happy new year in less than 2 weeks. We already mentioned that Proxima B orbits around a different star, so what do scientists know about the mysterious star? Get ready to be thrilled. Proxima B orbits around a star known as Proxima Centauri.
Proxima Centauri turns out to have at least one possibly Earth-like planet. Astronomers are calling this world Proxima B.
It is the closest star to our Sun, about 4.24 light-years away. But here's the unique part. Unlike the distance between Earth and the Sun, the distance between Proxima B and its star takes a unique arrangement. As a matter of fact, Proxima B is just a stone's throw from its star, being about 7.5 million kilometers away, which is very short compared to Earth, as it is just about 5% of the distance between the Earth and the Sun, with this figure also boasting to be a closer ratio than that of the closeness between Mercury and the Sun. With its combination of extreme atmospheric conditions, extreme temperatures, and a harsh reality, the question of life on the Proxima B is a tough one, pushing the boundaries on what is possible for the existence of life while testing the extent of resilience and adaptability needed for life to thrive in unfriendly conditions. Imagine the inhabitants of Proxima B battling both day and night simultaneously with extreme frying and freezing temperatures, trying to wipe out their existence without a moment of rest. Compared to the environmental condition of Proxima B, Earth is undoubtedly pure luxury for inhabitants. But what does life truly require to exist in a place, and what can we consider pure luxury? The answer lies in the world of discoveries that Proxima B promises. Though the discovery of Proxima is a groundbreaking feat for scientists, this is just the beginning of what scientists hope to achieve. Thanks to the James Webb Space Telescope launched in December 2021,
the James Webb Telescope is on board a European Ariane rocket which took off from French Guiana. It's the successor to the Hubble telescope.
more revelation about the exoplanet steeped thousands of light years away is being unveiled. With the information the telescope provides about planet, scientists are taking a deep dive into the versatility of the cosmos and what other planets in space outside our solar system are like. Studying Proxima B is a trip into the secrets of the cosmos, also causing us to explore on a deeper level an important question that continues to confront humanity, regardless of the technological advancement we've enjoyed. We are talking about questions regarding whether we are alone in the universe or not. So now that we've arrived at this point, let's explore the possibilities of life on Proxima B and what scientists have found. Proof of life on Proxima B. If you've been following, you would already know that the chances of life on Proxima B are slim due to the planet's extreme weather and atmospheric conditions. The surface temperature is around -10 to 30 degrees Celsius, depending on the atmospheric composition, and this gives us a clue on how harsh the conditions of the planet are. But while there is not much information about the planet's atmosphere, scientists believe it to be a thick atmosphere, possibly with liquid water present, thus bringing up the possibility of life existing on the planet. But how is the existence of water possible on a planet with so many extremities? Narrow your telescope as we explore the intricate rocky terrains of Proxima B for the answers. Imagine standing on the rocky terrains of the Proxima Centauri B, where the star is uniquely close enough to the planet that the planet cannot escape the heat, but the star is also far enough to allow for the existence of liquid water on the planet, thus making things more complex. This is the state of Proxima B.
The star's so-called habitable zone, where liquid water can exist, along with ice and water vapor.
Here we must also consider the planet's star, which is a red giant, which means it is much smaller and cooler than our Sun, making the possibility of liquid water on Proxima B very likely. But that isn't all when we consider the planetary conditions of Proxima B, which allows for the presence of water on the planet. It has been established that Proxima B has one part of it directly and constantly facing the Sun, and the other part left to outer darkness and icy cold, which is not all to the mysterious planet. As a matter of fact, scientists have also found a thin band which is the point in the planet between these extremities where both sides meet and merge into each other. This band is neither hot, cold, bright, or dark. Imagine a strip of twilight taking a chunk of the extreme sides of planet and creating a unique environment of its own. This part of Proxima B is referred to as the Terminator line. It is that narrow escape from the effects of Proxima B being a tidally locked planet, and this is where the discussion of alien life gets in the mix. If there is a place where scientists are more convinced that life could thrive on Proxima B, it would be this spot. Imagine microbes and other creatures clinging and holding on dearly to life in this twilight zone, thriving between the worst of conditions in eternal dusk as they make good use of the cold and warmth of both sides. While life on Proxima B is not assured, scientists are clinging to the hope and its numerous possibilities which the Terminator line provide. But as we broaden our horizons, it is also agreeable that life's existence might not be limited to the eternally cozy and habitable twilight zone of the Terminator line.
Proxima B sits close enough to its host to have oceans like the Earth, but scientists suspect it's tidally locked.
This is why we have the need to understand the planet and learn as much as we can from it remains paramount. Scientists can learn more about the cosmos from Proxima B, so you might wonder, how does the study of Proxima B work? The answer to this question points to telescopes. Proxima Centauri B orbits within its star's habitable zone, where liquid water could exist on its surface. Here, telescopes can gather information about the planet when the planet passes in front of a star, causing the star's light to filter into the planet's atmosphere. As this continues to happen, scientists can learn more about the planet, such as what chemicals are present on the planet. Here, questions like whether there is oxygen, methane, or water vapor on the planet can be answered. With more information on this being revealed, scientists can get answers regarding the existence of life on the planet. The planet's proximity to its star and potential atmospheric conditions make it an intriguing candidate for hosting life. However, there has yet to be any certainty about anything. Meanwhile, what if there's actually life on the planet? What would life look like for the inhabitants of Proxima B? Possible conditions of alien life on Proxima B? Well, we might have explored some dark and intriguing aspects of Proxima B already, but there is another factor about the planet that would make you terrified. Proxima B's star, also known as Proxima Centauri, is also a major threat to life on the planet. Despite being a red giant which is much cooler and smaller than our Sun, the star is known for outrageous, deadly solar flares. Imagine a solar flare that is so large and strong that it is 100 times stronger than anything we've seen from the Sun. That's exactly what we are talking about. We are talking about major tantrums that can rid the planet of its atmosphere, filling the surface with enough radiation and making it almost impossible for life to thrive on it. If life truly exists on the planet, as scientists suspect, it would have to be immensely resilient, adaptable to harsh conditions, and finding ways to survive despite frequent nuclear disasters. The possibility of life enduring such harsh conditions cannot be ruled out, as we've seen good examples of that happening even here on Earth. For instance, life thrives in the hottest springs and environments.
The side of the planet that's nearer the star is very hot. The side of the planet that's pointing away from the star is very cold.
As if that isn't enough, we've also witnessed the existence of life in the coldest depths of Antarctica, where no light gets to. Considering this, anything is possible, and we must be open to future discoveries about the Proxima B. But there is a more interesting part. Determining whether life exists on Proxima B is not easy, as scientists would need more tangible evidence to arrive at this breakthrough. While the dream of interstellar travel and going closer to the planet seems like a wild dream that is completely out of reach today, scientists are very hopeful when it comes to Proxima B. So what level are scientists at when it comes to interstellar travel to Proxima B? The answer is both sad and intriguing. Given our level of technological advancement and pursuit in the space race, interstellar travel is still only considered science fiction. For instance, it would take thousands of years for a mission to Proxima B to arrive, which means there is no hope of getting back information in our lifetime. But before you get sad about this realization, we must mention that improvements are underway. For instance, ambitious projects like the Breakthrough Starshot are working tirelessly to get tiny laser-propelled probes to the planet within a matter of decades to get more information on the planet. These probes would be propelled up to a fraction of the speed of light using lasers, thereby drastically reducing their arrival time at the exoplanet, which will be well within our lifetime. If projects like this are successful, the probes can send back pictures of planet, giving us a plethora of information. While projects like this are still being worked on, scientists are not folding their hands. In the meantime, the James Webb Space Telescope and other future missions will continue to help study Proxima Centauri B's atmosphere and potential biosignatures. Proxima Centauri B is undoubtedly an exciting discovery, offering a unique opportunity to study a potentially habitable exoplanet in unprecedented detail. But even if life isn't found on the planet, studying the planet is not a waste. Thanks to this planet, knowledge has been broadened in terms of our understanding of the universe and the infinite cosmos, of which we are a tiny part. Let's pivot to a different angle on Oumuamua's story. While the extraterrestrial hypothesis certainly gets a lot of attention, there's a range of natural explanations that offer their own intriguing possibilities. So, what if Oumuamua isn't an alien probe or an extraordinary object, but rather a very unusual yet natural cosmic traveler. First off, let's talk about the idea of outgassing. This is a process where a comet releases gas and dust as it gets closer to the sun. This release can create a sort of jet that propels the comet forward. If Oumuamua were a comet, its unusual acceleration could potentially be explained by this outgassing effect. As the object neared the sun, any ice or volatile compounds it carried could have sublimated, creating a thrust that changed its trajectory.
Something besides just the gravity from the sun and planets was affecting the trajectory of Oumuamua. A probable source of this acceleration is jets of gas coming off the object.
It's a natural process, though one that can produce some very peculiar results. Next, let's consider Oumuamua's shape and composition. Its elongated form might seem odd, but there's room in the natural world for such anomalies. Some researchers suggest that Oumuamua could be a fragment of a larger body, like a piece of a larger asteroid or a comet that broke apart. This fragmentation might have resulted in the unusual shape we observed. The object's rapid rotation also helps explain its elongated appearance. If it's spinning quickly, it might stretch out into a cigar shape due to centrifugal forces. Oumuamua's surface might have played a role in its behavior. The object's dark reddish color suggests that it's covered in a layer of organic rich material. This surface coating could affect how it absorbs and reflects sunlight, potentially influencing its motion. For instance, the way light interacts with its surface could contribute to variations in its speed and direction as it travels through space. Another intriguing natural explanation involves the idea of a cosmic collision. Oumuamua might have been part of a larger body that collided with something else, causing it to break apart and take on its current form. This kind of event could produce a fragment with an unusual shape and trajectory, adding to the object's mysterious nature. These natural explanations might not sound as exciting as the idea of an alien probe, but they're based on solid science. Processes like outgassing, fragmentation, and cosmic collisions are well known and could explain Oumuamua's unusual behavior without needing to assume it's from another world.
Still unraveling the mystery of Oumuamua.
Well, it's moving out of the solar system, and right now it's farther than the planet Jupiter.
One of the key aspects of scientific inquiry is considering all possible explanations and evaluating them based on the available evidence. In the case of Oumuamua, the natural explanations provide a framework for understanding its unusual features. The debate between natural and extraterrestrial explanations has not been about finding the right answer, but about expanding our knowledge and refining our understanding of the cosmos. Chapter 4. Oumuamua's Trajectory and Future Implications. When Oumuamua zipped into our solar system, its trajectory was anything but ordinary. It followed a hyperbolic path, meaning it came in from deep space, made a brief visit, and then headed out again, never to return. This kind of trajectory is a clear indicator that Oumuamua wasn't bound to our solar system. It was just passing through on a one-time journey. Its speed and trajectory suggested it was on a path that would take it out of our solar system and back into interstellar space. One of the intriguing aspects of Oumuamua's visit was how it challenged our understanding of interstellar objects. Before Oumuamua, we had never observed anything quite like it. Its arrival prompted scientists to rethink their models of how such objects travel through space. The sheer speed and unusual path of Oumuamua provided new data for astronomers trying to understand how objects from other star systems might interact with ours. Looking ahead, Oumuamua's visit opens up exciting possibilities for future space exploration. If we can detect and study more interstellar objects like Oumuamua, it could dramatically expand our understanding of the cosmos. Imagine sending a spacecraft to intercept one of these visitors. We could gather samples and data, providing first-hand information about the materials and conditions in other star systems. This could offer valuable insights into the formation and evolution of other planetary systems, and even help us learn more about the potential for life beyond our own solar system. With advanced telescopes and detection methods, astronomers are now better equipped to spot more cosmic wanderers. The more we can observe and study, the better our chances of uncovering the secrets they might hold. In addition to offering a glimpse into the past and future of interstellar travel, Oumuamua's visit raises interesting questions about the broader implications for our search for extraterrestrial life. Suppose more interstellar objects are passing through our solar system. In that case, they could potentially be carrying clues about the conditions and processes in other star systems. This could help us understand more about how life might arise and survive in different environments across the galaxy. While continuing to study objects like Oumuamua,
Oumuamua, the first known interstellar object to travel through our solar system, sped up unexpectedly while passing through our corner of the universe last year.
we embrace the sense of wonder and curiosity that drives us to look beyond our own world. The journey of Oumuamua has taught us valuable lessons about the nature of interstellar objects and has opened the door to future discoveries. Chapter 5: The Fermi Paradox and Extraterrestrial Life. Now, let's dive into one of the biggest and most perplexing questions in the search for extraterrestrial life: the Fermi Paradox. If the universe is so vast and potentially teeming with life, why haven't we found any evidence of it? This paradox adds another layer of intrigue to the Oumuamua mystery and sparks deep contemplation about our place in the cosmos. The Fermi Paradox is named after the physicist Enrico Fermi, who famously asked, "Where is everybody?" Despite the immense number of stars and potentially habitable planets in the galaxy, we haven't detected any signs of intelligent life. This contradiction between the high probability of extraterrestrial civilizations and the lack of evidence for their existence poses a significant challenge to our understanding of the universe. One of the leading theories that attempts to solve this paradox is the dark forest hypothesis. According to this idea, advanced civilizations might be deliberately avoiding contact with others to ensure their own survival. In a galaxy filled with potentially hostile civilizations, keeping a low profile could be a strategy to avoid attracting attention. Just like a hunter in a dark forest trying to stay hidden from predators, intelligent beings might be staying silent to avoid detection. Another theory is the zoo hypothesis, which suggests that advanced extraterrestrial civilizations might be aware of us but choose not to interfere, much like zookeepers observing animals in a zoo. According to this idea, Earth and humanity might be part of a cosmic experiment or observation, with aliens watching from a distance without making their presence known. These theories raise fascinating questions about the nature of extraterrestrial life and our place in the universe. If these advanced civilizations are out there, why haven't they made contact with us? Could it be that they're following strict protocols to avoid disturbing less advanced civilizations like ours? Or are they simply not interested in reaching out at all? The Fermi Paradox also touches on the idea that we might be looking in the wrong places.
Fermi Paradox is just, where are the aliens? If the universe is really 13.8 billion years old.
Or using the wrong methods to search for extraterrestrial intelligence. Our current technology and processes might not be advanced enough to detect signals from distant civilizations. We might be missing out on clues simply because we haven't developed the right tools or approaches yet. The implications of solving the Fermi Paradox are profound. Discovering evidence of extraterrestrial life would fundamentally change our understanding of the universe and our place within it. It would also have significant implications for fields like philosophy, religion, and science, prompting us to reevaluate our beliefs and assumptions about life and intelligence. Chapter 6: Wormholes and the Mysteries of Space Travel. Picture a cosmic highway slicing through the universe, offering a shortcut across enormous distances. This idea is not just science fiction, it is the concept of wormholes. These hypothetical tunnels through space-time might let us travel across the universe much faster than by moving through normal space. So, what exactly are wormholes, and could they be the key to making interstellar travel possible? Wormholes, often called Einstein-Rosen bridges, are theoretical passages predicted by Einstein's theory of general relativity.
So Einstein's general theory of relativity, which is our understanding of how gravity works in the universe.
Picture them as tunnels connecting two separate points in space-time. If they exist, they could allow a traveler to move between these points almost instantaneously, bypassing the usual space-time constraints. It's like folding a piece of paper and poking a hole through it. Suddenly, two distant points are just a short leap apart. The concept of wormholes has fascinated scientists and dreamers for decades. If wormholes exist and could be stabilized, they might revolutionize our understanding of space travel. Instead of spending years or even centuries traveling to the nearest stars, we could use wormholes to make those journeys in mere moments. Imagine sending a probe or even a human crew across light years of space in a fraction of the time it would take using conventional propulsion methods. It's a tantalizing possibility that makes us rethink what's achievable in our quest to explore the cosmos. However, there are some big ifs involved. For one, we have yet to find any evidence of wormholes in the real universe. Theoretical models suggest they could exist, but finding and confirming one is another story. Moreover, even if we do see a wormhole, there's no guarantee we'd be able to use it. Stabilizing a wormhole might require forms of energy or matter that we currently don't understand or can't produce. Some theories suggest the need for exotic matter with negative energy density to keep the wormhole open and prevent it from collapsing under its own gravity. Then there's the problem of how to navigate through a wormhole. Even if we manage to stabilize one, traveling through it could be extremely risky. Theoretical studies propose that crossing a wormhole might involve extreme gravitational forces or radiation, potentially posing serious hazards to any traveler. Think of it as trying to navigate a turbulent, uncharted tunnel through space. It is an exciting concept, but it comes with significant challenges. While wormholes remain a captivating part of our cosmic imagination, the idea pushes us to probe the depths of space and develop new technologies, and the dream of wormholes and interstellar travel keeps us motivated to push the boundaries of science. Chapter 7: Borisov and the New Era of Cosmic Exploration. Imagine it's 2019, and astronomers are once again stunned by a new cosmic visitor. This time, it's not Oumuamua, but a second interstellar object, a comet named Borisov.
Last summer, an amateur astronomer discovered the first interstellar comet zipping through our solar system, 2I Borisov. It was clear from its path that the comet would dim from view within months.
Just like its predecessor, Borisov brings with it a fresh wave of excitement and curiosity about the nature of interstellar travelers. But what makes Borisov so special, and what can it teach us about the universe? Comet Borisov was discovered by amateur astronomer Gennady Borisov in August 2019. Unlike Oumuamua, which was an elongated cigar-shaped object, Borisov was identified as a comet, a bright, icy visitor from another star system. As it zipped through our solar system, Borisov displayed a classic cometary tail, a sign that it was releasing gas and dust as it approached the sun. This outgassing provided a stark contrast to Oumuamua's mysterious absence of visible activity. What makes Borisov particularly intriguing is its role in the broader context of interstellar objects. Its arrival was a milestone, demonstrating that Oumuamua wasn't a one-off anomaly. Instead, the universe might be filled with these cosmic wanderers, and we've only just begun to scratch the surface. The fact that we've seen two such objects in quick succession suggests that interstellar visitors could be more common than we previously thought. Borisov's journey through our solar system provided valuable data for scientists. Researchers, by studying its trajectory and composition, could learn more about the materials that exist in other star systems. For instance, the specific chemicals and isotopes found in Borisov's tail could offer clues about the conditions and processes in its home system. This helps astronomers piece together a more complete picture of how different star systems form and evolve. One of the key takeaways from studying Borisov is the potential for future discoveries. With advancements in technology and observational techniques, we're now better equipped to detect and analyze interstellar objects. The next step is to develop even more sophisticated tools to catch these cosmic visitors earlier and study them in greater detail. Just imagine a future where we can intercept and explore these objects up close, gathering samples and analyzing them to uncover the secrets they hold. Borisov also highlights the importance of international collaboration in space exploration. The discovery of this comet was a global effort, with contributions from amateur astronomers and professional researchers alike. It's a reminder that exploring the cosmos is a collective endeavor that benefits from diverse perspectives and expertise. The more we work together, the better equipped we'll be to tackle the challenges and opportunities that lie ahead. In a broader sense, Borisov's visit reinforces the idea that our understanding of the universe is always evolving. Each new discovery adds a new layer to our knowledge and challenges us to rethink our place in the cosmos. The fact that we're encountering these interstellar visitors at all suggests that the universe is far more dynamic and interconnected than we previously imagined. So, as we look back on Borisov's journey and its impact on our understanding of space, we're reminded of the excitement and possibilities that lie ahead. Each new discovery, whether it's a comet, an asteroid, or something entirely new, brings us closer to unraveling the mysteries of the cosmos. As we wrap up our exploration of Oumuamua wormholes and the comet Borisov, we're left with a sense of wonder about the universe's mysteries. Oumuamua's unexpected journey has expanded our view of interstellar travel and reminded us that our solar system isn't as isolated as we once thought. Meanwhile, the concept of wormholes, though still theoretical, opens up exciting possibilities for future space travel. In the end, these cosmic phenomena inspire us to keep exploring and questioning. They remind us that there's still so much to learn and discover. As we continue to reach for the stars, let's embrace the excitement and mystery that drive our quest for knowledge. The universe is full of surprises, and we're just beginning to scratch the surface of its wonders.